Welcome. We will now review cloud networking and Amazon Virtual Private Cloud, also known as Amazon VPC. We will begin by reviewing fundamental concepts of AWS cloud networking, and you will then learn about the VPC as the foundation of an AWS cloud network infrastructure. After that, you will learn detailed information about the components that are defined in a VPC and examine some key configuration settings. In its most basic form, a cloud-based network is a private IP address space where you can deploy computing resources. In AWS, this private network space is provided by Amazon VPC. With a VPC, you define a virtual network in your own logically isolated area in the AWS cloud. You can deploy AWS computing resources inside the virtual network, such as Amazon EC2 instances or a database from the Amazon Relational Database Service. You can also define how and whether your private network space connects to endpoints in your network topology. In this example, a VPC contains 3 EC2 instances and 1 RDS instance. It is connected to the internet and the corporate data center. It is also connected to a secondary VPC. As a systems operator, you control these components. That's why it is important that you understand how to configure and use them. This diagram shows the main AWS networking components that reside in a VPC. It also highlights the key components that allow it to connect to external clients. A VPC can span multiple availability zones. Here's a detailed review of each VPC component we see here. First, there's a subnet. Subnets are logical subdivisions of your VPC. They enable you to segment your VPC into smaller networks in a single availability zone. The default setting of a subnet is private. When created, a subnet is an isolated segment in a VPC. A subnet is public if its route table contains a reference to a public internet traffic being processed by an internet gateway attached to the VPC. A subnet is required to deploy an instance into a VPC. The next component is a security group. A security group is a set of firewall rules that secure instances. They allow you to define inbound and outbound traffic to an instance. If you do not specify a particular security group at launch time, the default security group is used. A NIC is a virtual network interface that connects an instance to a network. Each instance in a VPC has a default network interface, also called the primary network interface, which cannot be detached from the instance. A router is a component that routes traffic within the VPC. Normally, you don't deal with a router, but instead you define route tables and attach them to subnets. An internet gateway allows communication between instances in a VPC and the public internet. A virtual private gateway can be defined on the AWS side of a virtual private network connection, also known as a VPN. A VPN connection provides a secure and encrypted tunnel between 2 network endpoints. A customer gateway is either a physical device or a software application on the client side of a VPN connection. When you create a VPC, you specify its allowable IP address range. This range represents IPv4 addresses. The IP address range is expressed as a classless interdomain routing or CIDR block. This required range is known as the primary CIDR block of the VPC. After you create the VPC, you can optionally add up to 4 secondary CIDR blocks for a total of 5 IPv4 CIDR blocks per VPC. You can only define VPCs with CIDR blocks of /16 through /28 inclusive. This means that a VPC can contain from 16 to 65,536 IP addresses, with a maximum of 200 subnets per VPC. As a best practice, restrict your range to addresses that are specified in RFC 1918. RFC 1918 defines the range of addresses that can be used by private networks. We recommend that you do not use a range that overlaps with addresses that are used by other VPCs. Doing so prohibits you from connecting these VPCs. You can also assign an IPv6 CIDR block that is provided by AWS. This CIDR block uses a fixed prefix length of /56. You cannot choose the range of addresses or the IPv6 CIDR block size. AWS assigns the block to your VPC from the AWS pool of IPv6 addresses. Remember, you can only have one IPv6 CIDR block per VPC. This AWS CLI command generates the VPC that is shown in the console screen capture. If the command completes successfully, it returns metadata about the new VPC. This metadata includes information like the ID and the state, which will show as pending. The CIDR format is used to specify IP address ranges when you create a VPC or a subnet. An IPv4 IP address is a 32-bit number represented as 4 numbers separated by periods. Each X is an 8-bit number, or a byte, that you can have a value between 0 and 255. The IP address is logically divided into a network prefix and a host identifier. The network prefix identifies the network, and the host identifier identifies the host. /n specifies the length in bits of the network prefix portion of the IP address, starting from the leftmost bit. For an IPv4 IP address, the value of n can be between 0 and 32. In a VPC, the value of n is restricted to between /16 and /28. In general, the larger the value of n, the smaller the range size becomes, which results in a smaller number of usable IP addresses. The table provides examples of CIDR block ranges, their corresponding bit representation, and their resulting address range. The first 4 IP addresses and the last IP address in each subnet CIDR block are not available for you to use, and they cannot be assigned to an instance. AWS reserves these. For example, in a subnet with CIDR block 10.0.0.0/24, the table depicts the 5 IP addresses that are reserved. For VPCs with multiple CIDR blocks, the IP address of the DNS server is located in the primary CIDR block. This diagram illustrates the main characteristics of a VPC. VPCs can span multiple availability zones in an AWS region. VPCs have an implicit router that routes all traffic in the VPC. VPCs have a default route table that specifies the allowed routes out of the VPC. This table defines a route, or rule, that allows all traffic for its CIDR IP address range to be routed locally. In the example, the VPC has an address range of 10.0.0.0/16. Therefore, its default route table has a rule to route all traffic that is destined for that range through the local route. Next, we examine how subnets and route tables are used in a VPC.